If I'm graphing something that's given to me in standard form, I can either convert it to vertex form, or the way that we graphed it is we first found the axis of symmetry. So we do x equals negative b over 2a, negative 2 over 2, 1, negative 2 over 2, negative 1. So it looks like this has an axis of symmetry, x equals negative 1. Axis of symmetry followed by vertex. My vertex for this is going to have a x coordinate of negative 1. The y coordinate I get by plugging that negative 1 back in to my original equation. If I plug a negative 1 into that, I'm going to get negative 1 squared plus 2 negative 1 plus 1. So 1 minus 2 plus 1. Oh, that comes out to 0. So my vertex must be negative 1, 0. So I go to negative 1, 0. That's my vertex. I need to find other points. I know I open up. I definitely open up because I have a positive 1x squared. It's invisible, but it's positive, so it smiles. It opens up. But how wide it opens up, I need to first plot some other points. I plug in numbers close to my axis of symmetry. Maybe I plug in 0, my y-intercept. That's going to be really easy. Plug in 0. It's going to be 0 plus 1. I get 1. So I have the point 0, 1. By mirror symmetry, I also must have the point negative 2, 1. Just for the fun of it, I'm going to plug in another number, like 1. If I plug in 1, I get 1 squared plus 2 times 1 plus 1. It comes out to 4. I have the point 1, 4. By mirror symmetry, I also must have negative 3, 4. So I know my parabola must look something like this. If I had something like this, I would find the axis of symmetry, negative b over 2a, and I plot that. I'm doing this fast because I'm trying to make short videos for you all. Oh, that's not the right number. Undo. All of this, garbage. Positive 3, x equals positive 3 is over here. That's my axis of symmetry. My vertex is going to be 3, comma, whatever I get if I plug in 3. If I plug in 3, I get negative 5. So 3, negative 5 is this point here. I know my graph's going to open up. I need to kind of make a table to get some other points, though, to figure out exactly how wide it opens up. I'll plug in numbers near 3, like maybe I'll plug in 2. If I plug in 2, I get 4 minus 12 plus 4. I get negative 4, so 2, negative 4 is on my graph. By mirror symmetry, so it's 4, negative 4. If I plug in 1, I get 1 minus 6 plus 4 is negative 1. So 1, negative 1. 5, negative 1 must also be a point. My y-intercept, if I plug in 0, I get 4. 0, 4. By mirror symmetry, also 6, 4. So my graph, this is going to be a fun one. Ready for this? This looks something like this. But a little less janky. If I'm in vertex form, I actually... Oops, ooh, that was neat. Ooh, neato. If I'm in vertex form, I actually don't even need to do as much work. My vertex is going to be 3, 6. So I'll plot the point 3, 6. That means I already know my axis of symmetry is here. It's going to be x equals 3. I just plug in a few points near 3 to get some other points to graph this. If I plug in something near 3, like 2, if I plug in 2, I get 2 minus 3 squared plus 6. That's negative 1 squared plus 6. 1 plus 6 is 7. 2, 7 is going to be on my graph. By mirror symmetry, I must have this. It's going to look something like that. One more. Oh, this is a bad one. I'm going to make it positive 3. It was going to open down. I'll explain why I changed that. My vertex is -5, -8. And I thought if I had the point -5, -8, you know what, let's even make it different. Let's keep it -3, but make this +8. Now, my vertex is going to be -5, +8. If I plot -5, +8, that's there. I know my axis of symmetry is x equals -5. Vertical line through the vertex. I plug in a few points near -5 to figure out what the graph looks like maybe I plug in -4. If I plug in -4, I'm going to have -3 times -4 plus 5 squared plus 8. -3 times 1 squared plus 8. -3 times 1 plus 8. -3 plus 8 is 5. So -4, 5 is on my graph. I must also have this point by mirror symmetry. So my graph is going to look something like this.